Problem 22 has a lot of factorials here. What does this mean? 6 factorial, 6 times 5 times 4. Look at my fancy 4. Divided by 2 factorials, 2 and 1. 4 factorial, 4 times 3 times 2 times 1. Now, who's going to cross out? Well, I'm going to go these guys, these guys, these guys, these guys, and I'm left with 30 on top. 6 times 5 is 30. On the bottom, 2 times 1 is 2. Gives me an answer of 15. Easy enough. All right, same thing here. 10 times 9 times 8 times ... times 2 times 1. On the bottom, I have a 2 times 1. And then I have 8 times 7 times ... 2 times 1. Who's going to cross out here? Well, the 8s, the 7s, the 6s, the 2s, the 1s, everybody. You're left with 90 on top. 2 times 1 on the bottom is 2. 90 cut in half, 45. And our final problem of the day, probably easier than the rest. It's 106 times 105 times ... all the way down to 1. We just need to show that it does stop. It doesn't keep going to negative infinity. Please note, if you try to do 106 factorial on the calculator, it's going to say error because it's too large. It can't do it. It can't do this problem. It can't. Let me repeat that. It can't do this problem, but you can. You are better than a calculator here. Other than that, you're going to lose every time. But hey, this time you're the best. 105s go away. 104s, 103s, everybody goes away. Left with 106 over 1. So 106 it is. We just beat the calculator.